today we're doing a concept that is kind of strange because you would never actually use this if you just had a calculator. If you had a calculator, this skill is not something you need, but in calculus we're going to use it. Okay, what we're doing today is called linearization. When you hear that word linearization, what do you think we're going to do? We're going to make lines. We are going to linearize functions. In other words, we're taking somewhat curvy lines and say, hey, what if this was a straight line? I bet it would be easier to do, and it is. That's the kind of the key to today. We're going to take somewhat funky looking lines and make them into a straight line to help us better understand them. It's not a perfect situation. It is going to give us approximations. It is not going to give me real answers. So if you look at this graph right here, okay, we've got this blue curve. That blue curve is this function, square root of x, e to the x minus 1. What I did was we made a tangent line to that graph right there at the point 1, 1. Okay, using that point, we did the tangent line of that graph. We drew the red line instead. Look at these two lines like right here. Okay, if I'm looking at this spot right here, would you say that those two lines, and notice the scale, like it's 1 and 1.5, are they pretty close together? Yeah, they're pretty similar. They're not the exact same, but they're pretty similar. So what we're going to do is we're going to use the red line to help us guess what the blue line is, or at least get pretty close to it. That's the key to today. All right, linearization. Let's do it. Letter A, write the equation of the line, equation of the tangent line at x equals 1. Okay, so write the equation of the tangent line. Basically, we're writing the equation of this red line here on my paper. All right, so as soon as you read the phrase, write the equation of the tangent line, y minus equals x minus. That's what we're doing here in part A. What is something that I know? What's my point? What's my x value going to be? X value is 1. What's my y value going to be? 1. It's a point on the graph. I can just look at it. It's 1, 1. I need to know the slope. And for us, it's really easy because they already graphed it for us. So if we look at that graph, and try to determine the slope. Let's see. We go up 1, 2, 3 over 1, 2. Yep. Slope is 3 halves. We put a 3 halves out in front, and we're done. Scale doesn't matter in terms of that. You could do it, but the scale's still going to match up because the scale is the same in terms of boxes. It's weird, but it works. My slope is 3 halves. Done. I wrote the equation of the tangent line. That's super easy. That's not the tough part of anything here. Now what we're going to do is we're going to use that tangent line to approximate the value of 1.1. Okay? We used 1 for a reason because 1 is pretty close to 1.1 and 1 is an easy number to use. Okay? But now we're going to use this equation to help us guess what 1.1 is going to be. So we're using this equation to help us estimate 1.1. So what do you think I'm going to do with that 1.1 in this equation of the tangent line? Yeah, we're plugging it in for x. This is an x value. Okay? We've got an x value right there of 1.1. So right there for our x value, we are going to plug in 1.1. Cool. And we're going to do it. This is non-calculator, so we're just simplifying it down. So y minus 1 equals 3 halves. What is 1.1 minus 1 going to get me? 0.1. And maybe it's easier to write this as a decimal instead of 3 halves. What could I write 3 halves as? 1.5. This is a non-calculator thing. This is about as hard as the math you're going to get. But let's say we had this. 1.5 times 0.1. What would 1.5 times 0.1 be? It is 0.15. You're multiplying by 1, so the number's not changing. But I got to move the decimal space one place because it's 0.1. So y minus 1 is equal to that. Then I'm going to solve. So all I have left to do is add 1. Y equals 1.15. Boom. Done. I approximated. This is the approximation of 1.1. We used a nearby point with easy numbers to help us approximate what the value would be at 1.1. Okay, this is silly because we would never really do this given our own devices. Okay? If I actually wanted to figure out what 1.1 is, all I would do is take my calculator and plug in 1.1 there. I can't do it without my calculator because I have no idea what e to the 0.1 power is, but I could. But this allows us to approximate without it. Does that make sense there? What about that value? So we got an answer. We got 1.15. That's our approximation. That's like right in here. Is 1.15 an over approximation or an under approximation? Is that number 2 bigger than the real answer or less than the real answer? And why can you tell that on your graph? Talk with your neighbor for a second. Is that answer bigger or less than the real answer? And how do we know that? Talk to each other. What do we think? Thumbs up, it's an over approximation. Thumbs down, you think it's an under approximation. What you got? Over approximation, under approximation. It is an under approximation. How can I tell based off of that graph that I'm having an under approximation? Absolutely, that's correct. Oh, in a very simplistic manner, we used the red line to make our answer. Where is that red line compared to the blue line? It's under it. So if it's under it, it's an under approximation. That's as much as you need to do, okay? But Evan said it correctly there. The blue line is concave up. Draw on your paper a line that is concave up. Draw any line you want. Make one that's concave up. Then draw a tangent line to it. So take a point and draw the tangent line. Where was your tangent line in respect to your actual graph? Under it. Okay, so this is an under approximation because f is concave up. That is the only justification I really need to state there. I would say, hey, it's an under approximation because f is concave up. Boom, done. Okay, because of that picture right there. It's impossible for you to draw a concave up graph without being an under approximation. Make sense? If I were to actually do this in my calculator, okay, here it is, my y equals, I typed in my equation. If I were to plug in 1.1, parentheses. If I were to plug in 1.1, I get 1.159. 1.159. That is what f of 1.1 actually is. Oh yeah, that's pretty close. We said it was 1.15, it was 1.159. And what's true about the answer we got approximating? It's below. It's less than what the actual answer was. So it just kind of proves what we said. Makes sense on the first one. Let's do it again. Okay. Find the linearization of this equation. So now we don't have a graph. Now we're just based off of an equation. So f of x, and we are going to use x equals 0. Find the linearization. Okay, cool. We're doing y minus equals x minus. I know what my x value is. It's 0. How could I find the y value? Plug it in. So if I plugged in 0, it would be 1 plus 0. So 1, square root of 1 is going to get me 1. So I know what my y value is. I got to find the slope. What can I do to find the slope? I'm looking for the slope of a tangent line. How do I do that? Derivative. I got to find the derivative here. Okay? So that is what we're trying to do. We got to find a derivative. Earlier we just looked at the graph, but now I got to find f prime of x. With your neighbor or by yourself here, take the derivative of f. See what you get. Here we go. F prime of x. I'm taking the derivative. Okay? A reminder that the square root of 1 plus x means 1 plus x to the 1/2 power. So if I'm taking the derivative there, Caden, what's the derivative going to look like? Good. Yeah, 1/2 in front, 1 plus x here. What's my new exponent going to be? Negative 1/2. And then he would multiply by the derivative of the baby. The derivative of the baby is just 1. So, yeah, that's my answer. Good. Rewrite the baby, derivative of the baby. Don't forget about chain rule. It's been a minute, but we can do it. That's f prime of x, which is not what I really wanted. I really want f prime at 0 because I want to know the slope at 0. This is equation of line at 0, so I'm plugging in 0. So it's 1/2. 1 plus 0 to the negative 1/2. 1 plus 0 is 1. What is 1 to the negative 1/2 power? Still 1, because the negative flips it, which is still 1. And then 1/2 power is the square root, which is still 1. Times 1/2 gets me 1/2. So that's what's going to go right there. That is the equation of the tangent line. That is perfectly good. All right. A couple years ago, there was a question on the AP exam where they said, write the linearization as L of x, which was really strange. And when I did it, it kind of threw me off. So I just want to show it to you. If you wanted to get fancy, you could get y by itself. What would I need to do here to get y by itself? Just add 1, right? If I just added 1, then y is by itself. And I could distribute this 1/2 over here. So 1/2 x, the minus 0 times 1/2 goes away. I'm going to add 1 to the other side. And you could call that the linearization. L of x is equal to that. All I did was get y by itself. You don't have to do that, but just be aware of it. If it's starting to throw you off a little bit, they did that a couple years ago and it bothered me, so I'm telling you. Okay? But those two things are exactly the same. It doesn't matter which one you get. That's part A. Let's do part B. Part B says use the linearization to approximate point 2. What are we going to do to approximate point 2? Plug it in. So we're finding the linearization at point 2, otherwise known as plugging in point 2. It doesn't matter which one you use. Okay, if you use my fancy new one, it's just going to be easy because everything's by itself. Or you could use the first one and do a tiny baby math. 1/2 times 0.2. What's half of 0.2? 0.1 plus 1. It is 1.1. That is the linearization at 0.2, which means it's the approximation at approximation at 0.2. We approximated what our answer is. That's what we think it's going to be. That is not the real answer. That's getting us close to it. Part C says use the second derivative to determine whether the tangent line is an over or under approximation. Do that with your neighbor or by yourself. Use the second derivative to decide if it's an over or under approximation. Go. We are using the second derivative. So if we're using the second derivative, we better find the second derivative. Okay, I got to figure out what the second derivative is. Dylan, what was your second derivative here? What? Give me the second derivative. Negative 1/4, because he multiplied by the negative 1/2. Yep. We wrote the baby, so 1 plus x is going to stay in there. What's my new exponent going to be? Negative 3/2, because it was negative 1/2, and we got to subtract 1. And then we would multiply by the derivative of the baby, but the derivative of the baby is 1. So that is my second derivative. Great. I want to know what the second derivative is at 0, because that's the whole point here, is I want to know what was the concavity at 0. Not at 0.2, but at 0. They should both get you the same answer, but I want to do it at 0. So I'm going to plug in 0. 1 plus 0 is 1. To the negative 3/2 is still 1. Times negative 1/4. What is true about f double prime at 0? Is it positive or is it negative? It's negative. So if it's negative, that means I'm concave what? Down. Draw a picture on your paper of any graph that is concave down. Draw a graph that is concave down. Draw a tangent line on that concave down graph. What is true about that tangent line? Is it an over or under that line? It's over. Grace. Because I wrote my tangent line at 0. So the question was, why did I plug in 0 instead of 0.2? Because when I made my tangent line, just like up here, the tangent line touched at that spot right there. Now, the good news is for everywhere on this graph that we're describing, the concavity would be the same. Because if the concavity changed again, then we couldn't use that approximation. Okay, so we're assuming that the concavity is the same during that time interval. So it really wouldn't matter, but we want to use 0 because that's where we originally made that point. Normally on the AP exam, they're very clear on that. And they're like, hey, it is concave up during this whole time interval or something along those lines. But that's a good question. Okay, so again, since I'm concave down and I'm using that point, we have an over approximation because F is concave down. That is all you need to state, but that is your justification as to why it's an over-under approximation. I would always draw that picture. I would never memorize that. I just think, oh, I'm concave down, draw the picture, I'm above it, so it's an over approximation. Part D is just what's the actual value. Again, you wouldn't do this on your test because on the test, if you had your calculator, you would just use your calculator. But we could. You're taking the square root of 1.2. If I took the square root, I get 1.095. So f of 0.2 is 1.095. Is that pretty close to what we approximated? Yeah, pretty close. But is my approximation answer a little bit bigger than what I thought it was going to, or what it actually was? Yeah, that's the whole idea of an over approximation. Makes sense on the second example. Let's go to the third one. Example 3. Okay, multiple choice. So same idea. Just don't do a multiple choice question. Don't let it be weird to you. Let f be the function given by this thing right here. What is the approximation? Found by using the line tangent to the graph. As soon as you read that, you know what you're doing. Line tangent to the graph. Y minus, x minus. Tangent to the graph at at pi over 2. We're trying to figure out what 1.5 is, and we're using pi over 2. So that means my x value is pi over 2. Use that to find the approximation. Work with your neighbor, work by yourself, get that answer. Go. So we try it, see what we can do. I need to know my y value. How can I find my y value? Plug it in. And so we're plugging in pi over 2. So it is 2 cosine pi over 2 plus 1. Pi over 2 is up here on my unit circle. What is cosine of that pi over 2 going to get you? That is 0. So this is 0 plus 1. My y value is 1. Boom, got it. Then I want to know the slope. How am I going to find the slope of this tangent line? Derivative. So I better find the derivative. Okay, so f prime of x is going to be equal to, what's the derivative? 2 cosine x. Negative 2 sine x. Remember Snapchat, negative Snapchat. We're at cosine. So now we're down there at negative sine. So it's negative sine 2x. The plus 1 goes away. I want to find that derivative at pi over 2. So negative 2 times sine of pi over 2. Again, pi over 2 is up there. If I'm doing sine, that's my y value. It's 1. So my slope is negative 2. Negative 2 times 1. That's the equation of the tangent line. Once I have that equation, hopefully this isn't too bad. Now that I've got that, I'm going to plug in the value that I'm trying to find, 1.5. And at first glance, that makes it worse. Like, ugh, I got a decimal and I've got pi. But distribute in that negative 2. What is negative 2 times 1.5 going to get me? Negative 3. And negative 2 times pi over 2 is going to get me plus pi. Last thing I got to do is add 1 over. So if I add 1 over, negative 2 plus pi, pi minus 2, same difference. A little bit different, but you can handle that. Questions on 3. We did not have a lot of success on 3. Let's try 4. Do number 4 for me real quick. It's a very easy one, but see if you can do that one. Get it? Writing the equation of the tangent line. So we're doing this. We are trying to figure out the line at 5. So if it's at 5, I can plug a 5 in right there. What's my y value going to be? Well, right here it says that the y value is 8. What's the slope going to be? Well, right here it says the slope is 0. So we can throw a 0 in right there. So we get y minus 8 equals, well, I'll just leave it like that. Y minus 8 equals 0 times, I can plug in my x value, but that x value doesn't even matter because all I'm going to do is multiply by 0. And all I'd have to do then is add that 8 to the other side. Y equals 8. Done. It's weird because it became 0, but don't let that be funky to you. There's 4. Last one. Consider the differential equation. So earlier today, I had some students with some questions on that. We are going to do a whole chapter called Differential Equations. Okay, chapter 5 is called Differential Equations. All it means is they're giving you a derivative. Okay, here is the derivative equation. They told me that right there. Let y be the particular solution to the differential equation with the initial condition that f of 1 is 3. Basically just saying, hey, that's the derivative, and it goes through the 0.13, the original graph does. The key to this is write an equation of the line tangent to the graph of f. As soon as I read that, y minus equals x minus. What do I know for that line? What can I plug in? 1 and 3. I know that my y value is 3 and my x value is 1. What I have left to do is find the slope. And then I'm going to use that to approximate 1.4. Try that with your neighbor. Go. It is strange because there's a lot of numbers going on there, but when we write the equation of the tangent line, don't worry about this yet. Okay, when it says write the equation of the tangent line, don't worry about what we're approximating first. Do it without that. We are writing the equation of the tangent line based on what they gave me, and I'm doing it at the 0.13. So I plugged 1 and 3 in. This right here is going to tell me the slope. So if I'm doing the slope, dy over dx is going to be equal to my x value. Well, my x value for this ordered pair is 1 times my y value, which is 3 minus 1 all over 4. And so I've got 2 over 4. My slope is 1/2. That is what's going in right here. Once I got my equation of my tangent line, that unlocks the other value. All right, cool. Now I'm going to find out 1.4. So then I'm going to go everywhere where I have an x and plug in 1.4. That's 1/2. 1.4 minus 1 is 0.4. Then I'm going to add 3. Half of 0.4 is 0.2. Add 3. Add 3 over y equals 3.2. Linearization. All right, we could have kept going and done, is it an over or under approximation? We would have to know more information in order to find that second derivative. Questions with something we did today?